Hello, my name's Mark Saunders, and this is a YouTube video presentation on the chi-square test, which we use to test statistically whether two variables are independent. It's one of a series of YouTube presentations on my YouTube channel, Mark Saunders on Research Methods, and you can see the link to this on the bottom left hand side of every slide. Let's start with an overview of hypothesis testing using the chi-square test, and we'll start with some definitions. Hypothesis testing is assessing the statistical significance within a sample of the independence of two categorical data variables by testing a hypothesis. The hypothesis is our tentative explanation of the dependence between these variables or the association between them. Conversely, the null hypothesis is saying that there is independence or no association between the two variables. So we might phrase this as there is independence, i.e. no association between the meal purchased by customers and their nationality. Our hypothesis would say there is dependence or an association between the two variables. In other words, there is dependence and association between the meal purchase and nationality of a cafe's customers. When we test for independence using the chi-square test, we are testing to see whether two categorical variables are independent. In this table we have two categorical variables. We have the nationality of the customer and the last meal they purchased. And the categories are, in terms of nationality, British or overseas, and the meal purchased is either breakfast or lunch. The first assumption that the test has to satisfy is that the categories in the table are mutually exclusive. This means that each observation can only fall into one cell. So if a person is British, then the last meal they could have purchased is either breakfast or lunch, but they could not have purchased both as their last meal. Similarly, if a person is overseas, if the last meal they could have purchased is breakfast or lunch. And similarly, if the person is overseas, they cannot be British. So each category or each cell, the number in it is mutually exclusive. That's the first assumption of the test. The second assumption of the test is that no more than 25% of cells in the tables have expected values of less than 5. Or for 2 by 2 tables like we have here, which has 2 rows and 2 columns, the 2 rows being breakfast and lunch and the 2 columns being British and overseas, expected values of less than 10, and that's no more than 25%. So if we look at this the table now, which has our expected values rather than our observed values, we can see that one of the 4 cells has an expected value of less than 10. So that's fine, because that's 25% rather than more than 25%. The chi-square test compares the observed values, which we saw in the previous slide in our table, what is expected if the two distributions are entirely independent, and that's what we've got calculated in the table now. It looks at the likelihood of the table data, so the table in the previous slide, or data more extreme occurring by chance when making this comparison. And when there's a low likelihood, in other words a p or probability of less than 0.05, we normally consider that this is statistically significant. Let's have a look at some other examples of observed and expected values. So here we have another table of data where our data is looking at the different sites for a company, the north site, the south site, the east site and the west site, and the number of employees employed in each site in production, administration and sales. And so we have our data there of 24 people employed in production on north site, 10 people employed in production on the south site, 34 on east site, and 62 employed in production on the west site, giving us a total of 173 employees. So that's our observed values. And as we can see, again, the categories are mutually exclusive. If a person is employed on the west site, they would not also be employed in production on the east site, and so on. We can now calculate our expected values, and what we can see here is the number that we would expect to have occurred if there was no patterns whatsoever. And here we can see no cells in the table have an expected value of less than 5. And this means that our assumptions of the chi-square test are satisfied. However, this is not always the case. Let's now look at observed and expected values for a chi-square table when assumptions are not satisfied. So in this table we have the number of firms by size, so 0 to less than 10 employees, 10 to less than 50 employees, 50 to less than 250 employees, and 250 plus employees, and for two different sectors, manufacturing and services. And this is for a geographical area in a region. So those are our observed values. Let's now look at the expected values. And when we look at the expected values for these mutually exclusive categories, we see that once we get to the larger firm size, we have very small expected values. We have for 50 to less than 250 employees in manufacturing, we have 2.2 firms. And in services, we only have 4.8 firms. And the decimals are here because we're calculating what would be expected if there wasn't any pattern. And so we can have decimal places within that. And what we see here in this table is more than 25% of cells in the table, in fact it's 50%, have expected values of less than 5. And despite the categories being mutually exclusive, the assumptions of the chi-square test are not satisfied. This means with the table as it stands, we cannot take the data and calculate a chi-square test. However, there is a way around that. What we can do with our data is we can actually start to group the categories. So what we've done here for our observed values is we've created a new category, a firm size of 50 or more employees. And what we see now is that the number of manufacturing firms in this size has gone to 4 by adding the 50 to less than 250 and the 250 plus firms, and similarly for services. We obviously have to check that the assumptions are satisfied by calculating our expected values. And now what we can see is we only have one expected value out of the 6, which is less than 5. And so we can say that less than 25% of our cells in the table now have expected values of less than 5. And so consequently, the assumptions of the chi-square test are now satisfied. Let's now move to looking at hypothesis testing using the chi-square test. And we're returned to our data set of the cafe with customers being either British or overseas, and for their last meal having purchased breakfast or lunch. To test the hypothesis, we calculate a test statistic, which is the chi-square test, the degrees of freedom, and based on this, the statistical significance level. When the probability of our test statistic value, or one more extreme, occurs at less than the prescribed significance level, and here we're saying less than 0.05 or 1 in 20, this provides us with evidence against the null hypothesis. So we have a chi-square test statistic of 28.107. Our degrees of freedom, because it's a 2 by 2 table, are 1. And our probability is in fact less than 0.001, so less than 1 in 1,000. Our data are therefore compatible with the explanation we expressed in our hypothesis earlier. There is an association between meal purchased and nationality. Let's now move to look at what this data would look like if we were perhaps undertaking an analysis using SPSS. We start off with a data set where we'd relate each of the data values to an identifier so that we could get back to the original data and how we'd collected it, perhaps using a questionnaire. And there's our identifier, and there are individual values for each so we can do the relationship. And we've got here two variables: meal purchase, which is the last meal purchase, which is a categorical variable, and nationality, which is also a categorical variable. And we code these data using a number to represent the category. For meal purchase, the code 1 equals breakfast and the code 2 equals lunch. For nationality, although we have the same numbers, these codes for this variable represent different things. So 1 represents British and 2 represents overseas. And where we only have data values recorded for one of these variables, we have to exclude this from any analysis involving both variables. And that's our simple data matrix. So each row represents a separate data set case, and each column represents a separate variable. We then have our hypothesis for the chi-square test. Our null hypothesis, represented by H0, is there is no association between meal purchased and nationality. And our hypothesis, represented by H1, is there is an association between meal purchase and nationality, and these obviously refer to this specific cafe. The test statistic chi-square with 1 degree of freedom equals 28.107 with a probability of less than 0.01. And the probability of a test statistic or one more extreme more occurring being less than 0.001 means we can reject our null hypothesis. We can report these findings in our thesis, our research report, or our dissertation, or a project report. And how we do this, we would say there is a significant association between meal purchased and nationality, and then we quote our chi-square statistic in brackets afterwards. And we then probably do a little bit more interpretation. And we'd say the cafe's British customers were more likely to purchase lunch, whilst their overseas customers were more likely to purchase breakfast. And we might represent this by a small graph, perhaps drawn in Microsoft Excel or indeed within SPSS. And that really is the overview of the chi-square test. But let's now look at selected further reading. And in this Dancing Ready's book, Statistics Without Maths or Psychology, talks about the chi-square test in chapter 9, and this book looks at the chi-square test in relation to using SPSS. Andy Field's book, Discovering Statistics Using SPSS, also talks about the chi-square test in chapter 19. And finally, my own book with Phil and Adrian, Research Methods for Business Students, considers the chi-square test in chapter 12. I hope you found this YouTube video presentation helpful. Please do look at my other video presentations on the channel, Mark Saunders on Research Methods, and it would be fantastic if you could subscribe to the channel. I'm adding new video presentations pretty much on a weekly basis. Thank you.